Hey there and welcome. Today we're going to be venturing into the world of Soulbound NFTs. So what are Soulbound NFTs? So basically, these Soulbound NFTs are NFTs that you cannot transfer, buy or sell. So what are the use cases of these Soulbound NFTs? So one use case for Soulbound NFTs are for online certificates, where you will issue this certificate and this particular certificate will be with the user forever. Second use case is for the in-game items. So these in-game items, this special in-game item, won't be associated with a particular player or a character. So without further ado, let's go create our smart contract. So first thing we need to do is in our browser, we can go to remix.ethereum.org right here. And we are going to use Remix IDE for this video. So this is the IDE that we are going to use to write our smart contract. Okay, so now in Remix, what we need to do is to create a new file first. To do that, you can just click this paper-like icon and then name our file Soulbound NFT.sol and press enter, and it will create a new text editor pane right here. This is where we are going to write our smart contract code. Okay, without further ado, let's start writing our smart contract code for our Soulbound NFT. First, we need to write this line of code, spdx-license-identifier MIT. This line of code just identifies which license we are going to use for our smart contract. In this case, the license will be MIT. The next line of code is pragma solidity carat 0.8.0. Now this line of code is a required line of code in Solidity. It just designates which version of Solidity we are going to use for our smart contract. In this case, it is 0.8.0 and above. Okay, now let's continue. Now we are going to import 3 other smart contracts from OpenZeppelin, and I will paste them here. And now these are the 3 imports that we have from OpenZeppelin. The first one is the ERC721 URI storage.sol. Basically, this is a smart contract with functions written inside of it that is based on the ERC721 standard. So if you're not familiar with ERC721, it is the standard for writing NFTs smart contract. Since we are writing NFTs in this video, so we are going to use the ERC721 standard. The next import is the ownable.sol. So this ownable.sol, it is a library that has added utilities for us. So the function of this smart contract is to basically track the ownership of the smart contract. Ownable.sol has other functionalities included inside of the smart contract, like you can renounce ownership, or you can transfer ownership from one person, from one wallet address to another. Next is the counters.sol. So again, this one is another utility from OpenZeppelin. So what counters does is it gives us the ability to have a counter that can be incremented. Okay, now that we are done with the importing of the smart contracts of OpenZeppelin, we can now proceed to the next line of our smart contract. This time, we are now going to declare our smart contract. So in order for us to write the smart contract, we first type the keyword contract, which means that we are now starting the smart contract, followed by the name of our smart contract, which is Soulbound NFT. Next is the keyword it, followed by the smart contracts that we have imported from OpenZeppelin, and those are ERC721 URI, storage, and ownable smart contracts. And we end this line with the curly brackets. So our smart contract is inheriting from ERC721 storage and ownable.sol. And once you inherit a smart contract, basically everything that is contained within these 2 smart contracts will now be available in our own smart contract. Okay, so let's proceed now with the next line of code. The next line of code, we are going to type using counters or counters.counter. So what this line of code does is it basically What this line of code does, it utilizes the counters.sol that we have imported here from OpenClayer. So now that we have initialized the counters object, we can now create a new variable that is based on the counters.counter data type. In the next line of code, we are going to initialize a variable called underscore token ID counter. And that particular variable will be based on the counters.counter type that we have imported right here. Counters.counter private, since we don't want anyone to basically see our counters, to basically see our token counter. And then followed by the variable name, which is underscore token ID counter. And we are initializing it to 0 with this line. Next line is we are going to define our constructor function. So constructor, close open parenthesis, our constructor will basically not take any parameters for this project, for this smart contract. Followed by the ERC721 right here function. We need to supply this function since we inherited the ERC721 storage.sol from OpenAffiliate. And inside this function, it basically needs two arguments. And the first argument is the name of our NFT. So I'll just name it I'll just provide a simple name for this one, which is a Soulbound NFT. And then the second argument for this one is the symbol of your NFT collection. And this one, I'll just name it SLB-NFT. And then followed by curly brackets. And inside the constructor, we don't want to execute any code once we deploy this smart contract. So we'll just leave the constructor functions or the constructor code block empty. Next, we are going to create a function called safeMint. In order to do that, we need to type first the keyword function, and then followed by the function name, which in this case is safeMint. Followed by open and close parentheses, and inside of those parentheses, we will be adding parameters for our function. The first parameter is the address to, which means this is where the address where we are going to send the minted NFT. The next argument will be string memory URI. This one is the URI where the metadata of this particular NFT is located. And this function will be public. And we have the modifier only owner here, which means that only the owner can use the safeMint function. And only owner, this particular modifier comes from the ownable.sol that we have imported. And since ownable.sol tracks the owner of this particular smart contract, then we can use this only owner modifier and say that this particular function safeMint is restricted to be called only by the owner. So inside of this function, we create a variable called token ID, uint256 token ID, which is derived from the token ID counter that current. So we initially have this token ID counter, this one, and initially this is initialized to have a value of 0. And we basically just returns, in this line of code, underscore token ID that current basically returns the current value of token ID counter. And then we just assign it to the token ID variable right here. And then after that, we increment the token ID counter by calling the increment method. So these methods, increment and current, they are contained inside the counters.sol right here. And since we use counters.sol here by including these lines of code, then we can call this two methods. Next is to call the safeMint function and to supply it with two arguments. The first argument is the to, and the second argument is the token ID. So this underscore safeMint function basically came from the URI 721 storage.sol smart contract. So basically, this smart contract contains all the logic to mint the function right here. So basically, the ERC721 URI storage.sol smart contract contains all of the logic for the safe mint function that we used right here. Next is we set the token URI to the token ID and the URI. And this set token URI, it also came from ERC721 URI storage.sol. And this is basically the content or the definition of our function SafeMint. So next function that we are going to create for this smart contract is the function called Unequip, which basically takes one parameter only, which is a UIN 256 token ID. And this function is basically external, right here. Inside of this function, we will add a require statement that checks whether the owner of this token ID is equal to message.sender. So if it's not equal to the message.sender, then we will revert this transaction and give an error that says that you are not the owner of this NFT or something like that. And in the next line, we then burn this token. Okay, so what is the function of this unequip function? So the functionality of this unequip function is to have this Soulbound NFT disassociate from our wallet address. So for example, I have a particular NFT, Soulbound NFT, and I don't want that particular NFT anymore in my wallet. Then I can just unequip that NFT and it will now be removed from my wallet address. So that is the function of this unequip function right here. The next function that we need to create is called the revoke function. So function revoke, and it will again take one parameter, which is the same as unequip, uint 256 token ID. And this time, this function is external and only the owner can call this particular function. And inside of this function revoke, we call the underscore burn function and supply the token ID. So what this function revoke does is the owner of this particular smart contract has the ability to remove a particular Soulbound NFT to a user. So for example, a user violates the terms and condition of this particular smart contract, then the owner can just revoke that particular NFT that is associated with a particular user. So that is why we need to have this function revoke. So the next step for this smart contract is to override a function called underscore before token transfer, which resides inside the ERC721 URI storage.sol. So in order for us to override that particular function, we can just hold control and then click this smart contract, and inside of the ERC721 story.sol smart contract, we have another import here. And again, control click that one, scroll to the bottom part, and you will see this line. So initially in the implementation of ERC721.sol by OpenZeppelin, this function is empty. And this function is set to virtual, so we can basically override this in our own smart contract. For us to do that, we can copy this line, and then go back to our smart contract, and then paste it right here. Since we are going to override this function, we need to add another modifier here called override there. And yeah, let me fix the formatting of this code for quite a while. So after formatting this function, the way like this one, we can now add the code that we are going to run inside of this before token transfer. So the only code that we're going to run here is a require statement. So require, where the from address should be equal to address 0, or the to address is equal to address 0. Otherwise, we will revert this transaction and we will provide a message that says you are not allowed to transfer this NFT. So there will be two warnings here, this one and this one. The warning just states that it is a unused function parameter. So in order to silence that warning, we can just do this. First token ID and then batch size. So we just need to use these two parameters inside of the function definition right here. So let me explain what this function before token transfer does. So this function is executed every time you transfer a token. So before you transfer a token, this is basically executed, and initially based on ERC721.sol's implementation, of OpenZeppelin, this function is empty. But in our case, in our smart contract, we need to require first if the from ID here is equals to address.0, which means that this is the minting part of the NFT. Or we require that the to address is equals to address 0, the to address, which means that this transaction or this transfer is basically a burn transaction. So yeah, so if the from address is the address 0 or the to address is the address 0, then this transaction or the transfer transaction will push to. Otherwise, it will revert and gives us a message that says you are not allowed to transfer this NFT since this is a soulbound. Since this is a soulbound NFT, so you cannot transfer this NFT to anyone except to mint and to burn it. Now that we are done writing our smart contract, we can compile and deploy it to the blockchain network. So first, we need to compile it. Go to this tab right here, Solidity compiler, and just click compile Soulbound NFT. That's all. So if there are no errors, it will give you a green check mark right here, which means everything is okay. Now go to the deployment tab. Now that we're done compiling our smart contract, we can now deploy it. Just go to this deploy and run transactions tab. In the environment, change it to injected provider MetaMask. And it should reflect the 80,001 network if we are connected to the Mumbai testnet. And we are going to deploy the smart contract in the Mumbai testnet. So also I have some test tokens right here. And my account should be the same as my account here in the MetaMask wallet. The gas limit is set by default. The value also, and then for the contract, make sure that it is the Soulbound NFT, and then click deploy. After clicking deploy, MetaMask will pop up asking you to confirm the transaction, which is contract deployment. Then click confirm, and wait for the transaction to be successful. Once the transaction is successful, you can see the green check mark button here, denoting that the transaction is successful, and you can also see the deployed contracts right here. Just click this arrow button right here to expand the smart contract. So you can see some other functions right here. These other functions basically are inherited from these two smart contracts that we have imported right here. In this video, we're going to focus on the three functions that we have created right here, which is safe mint, unequip, and revoke. So this is the revoke function, this is the safe mint function, and this is the unequip function. Now we're going to mint an NFT, a Soulbound NFT. So in order for us to mint an NFT, we would need the token URI. I have here a sample of token URI. I will just paste it here at the bottom. So this is a ready-made URI that I have prepared early on for this session. So I'll just copy it, and then in the SafeMin function, just press this arrow button and paste the URI string right here. And the address, it is basically the address where you want to mint the NFT. So in this case, I want to mint this NFT and send it to my account. So I'm going to copy my account and paste it here, and then click transact. Once you click transact, MetaMask will pop up indicating that you are interacting with this smart contract, and the function that you are executing in the smart contract is this SafeMint function. Scroll down and then click confirm, and wait for the transaction to succeed. Once this transaction is successful, you can see again a green check mark right here. So in order for us to check the NFT, we can go to OpenSea right here, and we should connect our wallet first. Right here, connect our wallet, MetaMask will pop up. Next, connect, accept and sign, and then my wallet is now connected to OpenSea. And just hover over this circle icon and click profile. And now you should see this Soulbound NFT that is recently minted. So let's open it up, and you can see here some details for the NFT. Now let's try and transfer this particular NFT. Just go to this page, profile page, and then just go to your profile page, and in this button, click this button, more options, and then click transfer. Now I will try to, this is my account 1. So now I will try to transfer it to my second account, which is this one. So I will copy my address and paste it here, and let's see that, and click transfer. And you can see that the execution is reverted, which means that basically you cannot transfer this particular NFT to anyone except the address 0. So I can click continue for as long as I can, and it will still revert. Okay. So now let's discuss this function and unequip. So now I have this Soulbound NFT inside of my profile. For example, yeah, so I now have the blah blah blah. So now I want to basically remove it from my profile. So what I can do, since I cannot transfer it to other users, what I can do is instead execute this function unequip. So this function unequip. So that token ID for this particular NFT will be token ID number 0, since we initialized our token ID counter as 0. So we can just pass that token ID to this unequip function. So this particular NFT is now associated with my wallet address. And let's go back to Remix, and we can check here the owner of, and it accepts a token ID. So we can put the token ID 0, which is the first NFT we have minted in this smart contract. And why 0? It's because the token ID counter was initialized to 0. Yeah. Click this owner of, and you can see now that this address it returns here is the same as my wallet address right here. Sorry, right here in my account 1. It's the same as this wallet address in my MetaMask wallet, which means that I am the owner of this particular token ID. So now let's execute the unequip function by passing the token ID of 0. Click unequip, and then MetaMask again will pop up saying confirming your transaction. Then just click confirm and wait for the transaction to succeed. So now that transaction has succeeded, and let's return to our OpenSea profile, then refresh it, and now you can see that the NFT, the Soulbound NFT, is now gone from our profile or our account. So now we are going to discuss what this revoke function is, or what it is trying to do. So back in OpenSea, I have logged in a different account right here. This is my second account in my MetaMask wallet. And I already minted a certain NFT. This one, Knights of Valor Soulbound NFT. So now, when we go back to Remix, so in Remix, I have logged in as the first account, the 88B2 account. And if I tried, so back in Remix, I am the first account. I have logged in as the first account, which is 88B2. And I can check who the owner of the particular token ID number 1. And let's check it. And you can see that this is the owner of the token ID number 1, which is my second account in my MetaMask wallet, account number 2, right here. So now, since I am logged in as my account 1, 88B2, if I tried to unequip an NFT that I am not the owner of, it will give you this error. JSON RPC execution reverted. So basically, it gives us the error, you are not the owner of this NFT, which is, let's cancel first, which is this one. So unequip checks first if we are the owner of that particular token ID. If it's not, then it will revert the transaction like you have seen earlier. So now as an owner of this particular smart contract, what if you want to revoke the NFT of a particular user? So even though you are not the owner of that particular NFT, so long as you are the owner of this smart contract, then you can revoke those NFT. So earlier I demonstrated to you that the NFT token ID number 1 is not owned by our account, by the 88B2 account. So what we can do is execute the revoke function to revoke that particular NFT. So let's see, and pass the token ID number 1 right here and click revoke. Again, MetaMask will pop up asking you to confirm the transaction, which is revoke. Scroll down and click confirm and wait for the transaction to succeed. So once the transaction is successful, it will again give a green checkmark button right here. You can go to our OpenSea profile for our second account, E853. Refresh the page, and you can now see that we don't have any NFTs for this account. The NFT basically is revoked from this user. So that is how you write a smart contract for a Soulbound NFT. So this Soulbound NFT, these are very useful for certificates. For example, a certain user has managed to complete an online course, then you can issue this Soulbound NFT as certificate. And only you, as the issuer, can have the ability to revoke that particular NFT. Also, another application of this is in games, online games, or NFT-based games. So for example, you have a special in-game item that people can have, and that particular item will be soulbound to that particular account, which they cannot transfer, since it designates some special kind of achievement to get that particular item. Congratulations in completing this Soulbound NFT smart contract, and I hope you had fun learning about this NFT. I hope you had fun learning about this Soulbound NFT, and I hope you can put it to good use. So goodbye, and I hope to see you again on our next video.